Welcome. Hopefully you watched the lecture. Hope it wasn't too boring and you took some notes down. Here's a chance that hopefully, first of all, you tried page 4 and 5 and maybe struggled, or you want to check your answers. I'm going to go through every single question, try to explain it as best as possible. If you're just looking for answers, you can maybe fast forward. If you're looking for a little explanation of why something was what I got or something, take a little bit of time and I'll watch that. So here we go. So I'll share my screen with you guys. And here we go. So here's page 4 right here. So the first one says, let me annotate here. Examine the forces acting on the freezer in the diagram and answer questions 1 through 3. Number 1, are any of the forces acting on the freezer balanced? Now, I think the key word there is balanced. Remember, when it's balanced, there's 2 forces, but they're equal, so nothing's moving. Now, if I look really close here, I'm looking at my forces, and I'm going to kind of circle them for you. I have my push or my applied force, my friction force against the movement, and then I have this, they're calling this W force. Well, that's they're calling it weight, but that's really gravity. And then my normal force. Now, if you look at the arrows, and especially the W arrow and the N arrow, gravity and normal, they are the same size but opposite direction. So that is a balanced force. We don't even have to look anymore. That is yes. Now, the next part, we already said what it is. If so, which ones? Now, I don't like the W one, but I'm going to put it there. And that's really gravity. So let's spell out gravity. G-R-A-V-I-T-E. Sorry there. Gravity. Now, and the other one would be N, and that's our normal force. It is resting, if you will, on the floor. All right. Number 2, are any of the forces unbalanced? Of course, that answer is yes. And we can tell, because if we're looking at the push force and the friction force, you can see the size of those arrows are different. So yes, which ones? Let's do F, or the push force, or we could call it the applied force, and the F, friction force. Friction. Missing my I in there, sorry. All right. The last question on the freezer here is, describe the motion of the freezer. Well, is it going up or down? No. Is it moving left or right? It is. In which way is it moving? It's moving left. Again, we know it's moving left because the push arrow pointing to the left is bigger in magnitude than the friction going on the right. Doesn't give us numbers, but that arrow tells us. So our correct answer here is left. Okay, so there's questions 1, 2, and 3. I'm going to erase this, so if you need a second, pause it, copy that down, and then we're going to move on to questions 4, 5, and 6. All right, questions 4, 5, and 6 are all going to deal again with balanced or unbalanced forces. So question number 4 says, 2 men of equal strength, and that's a key point there, so I'm going to highlight it or underline it, of equal strength have a tug of war. Draw the forces that are acting onto the picture. Which man will win the tug of war? Well, remember, for us, we really have 4 forces that we're going to talk about. And I'm going to try to write him on the right. And so The one that we always have is F of G, that's gravity. F of N, that's our normal against gravity. And then we would have our force applied and our force of friction. And they could be gone in both ways. So when we first look at this one, I'm going to look, do we have gravity on Earth? Absolutely. So we always have to draw that one in. So here is an arrow I would draw in, and mine's going to probably be a little sloppy, but that's the force of gravity pushing down. Now, we have to have something that counteracts that because it's not getting pushed into the ground. It's not going into the earth. Something is stopping that. And that force, whatever it is, we call the normal force. So that's force normal. Now, my arrows aren't perfect, but that's a balanced force because that rope is not going up or down. It's staying in the same spot. Now, it's a tug of war, and I hope you know what a tug of war is, but these two individuals are trying to pull the rope. The guy on the right is pulling it to the right, and the guy on the left is pulling it to the left. Each one of these forces is not a friction force, but applied force. They're pulling on it. Now, the question is, which man will win the tug of war? Well, they're equal strength, and there's one of each of them. So it cannot be either left or right. The correct answer is neither of them will win. This would be considered a balanced force. All right, let's look at the next one. I'm going to change my color to green. Again, this one says, another man joins each end of the rope. Does this affect the result of the tug of war? If not, why not? Well, we can still say that we have our force of gravity. Oops, draw my arrow the wrong way. We have our force of gravity and our normal force. Again, those arrows should be the same size. And then we doubled the strength, if you will, the strength of the applied force to the right. And we did the same thing to the applied force to the left. So does this affect the tug of war? No, it's still a balanced force. So our answer would be no, still balanced. On number 6, one man joins the team to the left. Now, once again, we still have our, oh, come on, Mr. Foss, that's twice in a row. We still have our force of gravity pushing down and our normal force pushing up. But this time, the force applied to the right is not as strong. And notice this one's pretty easy to draw that arrow a little bit more than the applied force to the left. So who's going to win this time? The left side. They have a little bit more. So once again, if you need to pause, relook at that. But there's our 3 answers. And remember, it does ask to draw in these forces. So make sure you have the arrows and labeled just as I do, and it's really nice. The final answer is boxed in, so that's easy to see. So you got the red, green, and then the pink. So you need to take a second to pause, and then I'm going to move down to questions 7, 8, and 9. All right, so here's questions. I probably should keep this so we can see question number 6 because we're going to need those people. And let's use this color. So In the picture for question 6 above, each man pulls with a force of 10 newtons. Remember, newtons here is just our unit of force. So question 7, how much force does the team on the left pull with? Well, each one of these is 10. And we have 3 of them. So what we're really doing is adding them up. 10 plus 10 plus 10 is 30. So these guys on the left have a force of 30 newtons. Just like the other side, the right side, 10 plus 10, that will equal 20. So you have a force of 30 going to the left and 30 going to the right. It says now, number 9, explain the result of the tug of war using the values of the for the force in each team. Well, you have 30 on the left, an opposing force unbalanced, 20 to the right, is going to give us, we have a 10 Newton force, and then we always want to give it a direction where we're going. And who won this tug of war? The people on the left. So here we have a 10 Newton force to the left is the winner. All right, there's page 4. Again, stop if you need to. Check your answers, go back, whatever you need. Make sure that you have a good understanding for this. I'm going to move on to page 5. And I'm going to move it up and see if we can get through a couple of these questions here. So at any time, it's good to reference your notes. If it was me right now, I'd have my notes right to the side of me as I go through this. So number 1 says, circle the surface below that would cause the most friction if you ran your hand over it. Now, what we really want to think about here is the idea of friction. And I think we can all agree that a very smooth surface like ice is less friction. So if I look at these, A has got some bumps here. You can see a couple bumps in there. B actually looks really smooth, so I can take that one out. Now, if I looked at the difference between A and C, maybe they're close, but I think the best answer, if I would think of roughness, C would be the best answer there. It looked like it would slow my hand down if I ran it across. Number 2 says, assuming they are sliding on the same surface. So that means the surface is not going to apply here. Which object below would cause the most friction? If you look closely, it's kind of hard to see, but we have a 200 kilogram, a 50 kilogram, and 100 kilogram. Well, what 2 things affect friction? The surface, which again, we said that they're all the same, so that doesn't apply. And then the weight. In that case, then the heavier one will create the most friction. So that'd be 200 kilograms. I'm going to stop there so I can do 3, 4, 5, and 6 all together. So again, as usual, pause if you need to, go back, look at that, make sure that that makes sense. The big picture of number 1 and 2 is talking about friction, is looking at your surface area and the weight, and that's again in your notes. All right, so here's questions 3, 4, 5, and 6. And I think it's easier if I explain a little bit of these as we go. It says, which type of friction is being shown? This is question number 3. Now, here, it's hard to tell, but if we look down at question number 6, we can see the difference. Question number 6 tells us there's no movement. So here we're going to say that it's sliding. So what type of friction? This is our sliding friction. And then what we want to answer here in the bottom one is, well, what's going on here? So what happens with sliding friction? Well, these are both flat surfaces. So sliding friction, flat surfaces. And then I think the rest of them you could probably get on your own. You may have to look in your notes and look up the 4 types of frictions we had. But number 4 is our rolling friction. And as I'm writing this in, I'm thinking to myself, oh, what's my order of friction again? Which one is the creates the most friction, then so forth, and then the least as we talk about these. And what would be my description here? I would say something of like maybe round on a flat surface. I think in the notes we talked about this, or I used the reference of a car. That's why we use tires on like car wheels on a car, less friction, because we don't want a lot of friction when we move. We only want that friction when we stop. And then the number 5, it's got it in the word. Liquid is a fluid. Now, sometimes we also talk about a gas with these, but an example of this might be like in water. People who think about engines, we put oil in engines to help keep the friction down, because that friction creates heat, which is bad for your engines. So we use oil there, then that's a liquid to keep that friction down. And then the last one, again, this one is a little bit easier than that. Number 3 is because, again, we say no movement. And no movement is static friction. And again, it says it in the word, this is not moving. So those are the 4 types of frictions. Maybe if I'm doing this, again, I'm thinking to myself, which one is the has the most friction? Static would have the most friction. Then I would say sliding, then rolling, and then fluid. If you talk in general, this would be the least amount of friction. So again, they're just back from our notes, static, sliding, rolling, and then fluid. Again, I'm going to scroll down to the last questions on page 5, 7, 8, 9, and 10. So pause if you need to. Okay, so here is 7, 8, 9, and 10. It says, why would you want to decrease friction? I kind of gave a little bit of a hint up top on an engine. We put it in there to help that friction, and pretty simple is so we don't, how do I want to say it? Let's say we don't wear down, or I should say do not wear down parts. Especially in an engine, the pistons fire back and forth, and that metal's really close, and they rub, and we don't want that to do that. It can create some problems. So what are a couple ways we can decrease friction? Well, we already talked about it in the example above, like the engine. We can use like an oil, or maybe a better yet, a lubricant is what they call it. And that helps creates friction. And then another one to think about, or we've talked about, is we have 4 different types of frictions. Lubrications are the fluids, and they help out. But the next least one would be rolling. Use that somehow, and that's what we use. And I would say wheels. So we use that in our cars. Again, this is a great time to talk about this unit, because number 9 says, why would you want to increase friction? They don't do it as much anymore, but they used to put like snow tires on. And what do those snow tires have on them? Well, they have like the little metal things that stick out. If they stick out, they create more friction, and those would to help us to not slip. So that's a big reason here and an easy one. What are some ways to increase friction? Well, rougher surface. Remember, the two things that really affect friction are the surface and weight. So rough surface would be my first one. Now we could go all sorts of things here. We could talk about having the object being static on two flat surfaces. We could talk about weight because that would increase the friction. So maybe I'll write down here flatter surfaces and not moving. And then may add the word weight there, because again, friction is based on two things, the weight and then the surface. There we are. There is pages 4 and 5 explained with answers. So obviously I do expect that you have all these answers written down. And when I get back, if I didn't clarify something very well, please let's ask about it, make sure that we have a good understanding again as we move forward. So, all right, thank you.